Okay, so we're going to look at a few more motion questions in AS physics, focusing on kinematic equations and projectile motion. So here's the first question. The ball rolls down a slope, travels a distance of 26 meters, and it takes 4 seconds. The acceleration is the first question. So we've got distance, time, and the initial velocity, of course, is 0. So with that information, the best equation that involves those three, and also the acceleration which we're trying to find, is this one. Displacement S equals the initial velocity u times t plus a half at squared. And of course the first term drops out because u is 0, and that means we can rearrange and solve for a as follows. A equals 2 times the displacement S divided by t squared. So we'll substitute the numbers. 2 times 26 is 52 on top, divided by 4 squared on the bottom, which is 16. And punch that into the calculator. Acceleration equals 3.25 meters per second squared. Okay, then question B. It's asking us to calculate the speed of the ball after 4 seconds. Now, to do that, we'll just have to add a new page and use this equation. V equals u plus at. U is 0, so we simply put in the 3.25 for the acceleration we just calculated and multiply it by 4 seconds, which gives us 13 meters per second as the answer. And then part C of this question asks us to find the distance travelled during the 6th second. Now, we're going to use the same equation here, this one, twice more while we solve this part C. I'll show you that on the next page. The first thing really is to understand what's going on, and an easy sketch of a VT graph often clarifies things. If we know already from earlier work that after 4 seconds the velocity reached was 13 meters per second, and now we're asked to find the distance travelled between the 5th and the 6th second. In other words, this area here under the graph and so to do that we need to find out these 2 points as well, the speeds at 5 and 6 seconds, and that's why we need to use this little equation twice more. In order to do that, just plugging in 5 seconds and the 6 seconds. If we do that, we can calculate the speed after 5 seconds to be 16.25 meters per second, and the speed after 6 seconds to be 19.5 meters per second. So we can use those two numbers now to find this area here. Using the equation, S equals V plus U over 2, the average velocity, times the time. In this case, just the 1 second. If we put The final speed, of course, will be the 19.5, and the initial speed was the 16.25. The average speed times the 1 second into this equation, we get 17.875 meters as our answer. So, question 2, a ball is dropped vertically from a height of 2.4 meters. Given that the acceleration of free fall is 9.8 meters per second squared, calculate A, the speed at which the ball hits the ground, and B, the time taken. Well, in this case, for question A, first of all, we're given the displacement vertically to be 2.4 meters. We can assume, since it's dropped, that the initial speed is 0, and therefore to find the final speed, the speed just upon impact, the logical equation to use is v squared equals u squared plus 2as. Now we can simplify that straight away to simply equal 2as, because the u is 0, the initial speed. Then plugging in the numbers, 2 times 9.8 times 2.4, and then taking the square root of that, your answer should be 6.9 meters per second. The two significant figures. Part B, the time taken to hit the ground. If we use the displacement s equals ut plus a half at squared, the first term ut drops out, leaving us with just the half at squared. And basically rearranging and making t the subject would give us the square root of 2s upon a as the formula. Plugging in the numbers, 2 times 2.4 meters on top, and divide that by 9.8, and then take the square root, gives you a time of 0.7 seconds. Question 3. This time the ball is thrown vertically upwards. The initial speed is given as 15 meters per second. Once again, acceleration is 9.8 meters per second squared. So we're ignoring air resistance, and therefore the only force acting is gravity. Of course, this 9.8 needs to be a negative number to show that it's acting in the opposite direction to the initial velocity vector 15. A, the maximum height reached. Well, once again, the logical equation is the v squared equals u squared plus 2as equation, and this time the final velocity will be 0. That's the velocity at the maximum height reached point, because momentarily it will not be moving vertically at all. So simplifying and finding, or rearranging I should say, to make s the subject, we'd have this equation here, u squared divided by 2a. If we plug in 15 and divide it by 2 times 9.8, we get the answer 11.5 meters as our maximum height. And then for part B, the time to reach maximum height. In this case, the easiest equation would be the first kinematic equation, v equals u plus at. Rearrange and solve for time t. Would give us t equals u over a, because v is still 0 at the maximum position. So it's just u over a. Subbing in 15 and dividing it by 9.8 gives us 1.53 as our answer, seconds. And part C, the total time for the ball to arrive back at your hand will be simply double that time it takes to reach maximum height, so simply 2 times 1.53, which will give us 3.06 seconds.